you very difficult to manage and allow you to enter in this classroom, online classroom. Just a minute. Now, process, basic concepts. We have already discussed few things, few issues. Um, that means whenever a particular process is allocated, memory area is allocated for it. And what are the different section of this memory area? First one is your code section. Next is your data section. Next is your heap section, and another is your stack section. And between heap section and stack section, there is a backend space. Now, what is code section? The name itself signifies that in this portion, the code which you have written and compiled, and that means which is uh, executable to particular machine, that will reside in this particular memory area, that is the code section. And next is your data section. Data section stores the global data. You know what is global data and what is local data? That means global data is accessible throughout the program. That means in any portion it can access that particular memory area. So those variable values are stored in this particular section, that is data section. And what about the local data? Local data will be stored within the stack section. Local means local to a particular module, that means a particular function. Now, you know what is heap section? The heap section is basically used for your dynamic memory allocation. Now, so you have already implemented in malloc, calloc, realloc, etc., etc. So what is dynamic memory allocation? So you using these facilities, you can allocate memory during the runtime. That means whenever it is actually needed, based on the requirement, you can allocate a memory area. Who will allocate? Obviously, the operating system. You can send the request to the operating system through some system call, and it will allocate the memory area for your program. Now, it may so happen that, as you know, you can use malloc to allocate a specific memory area, and you can also use calloc, and you can also use realloc. Can you tell me, anybody, what is the difference between malloc and calloc? Anybody? Can you give me the answer? Please unmute your microphone. Please unmute your microphone and tell me what is the difference between malloc and calloc? Manvi Kumari, please unmute your microphone. Manvi Kumari, are you there? You can also write in the chat box. Shomana Chakraborty, what is the difference between malloc and calloc? What is dynamic memory allocation? Shomana, okay.
Yes,
Tell me the
sir.
answer, please.
Yes, sir. Basically, calloc takes, I guess, 2 parameters, and malloc takes only 1 parameter. And
So when you will use malloc and when you will use calloc?
during dynamic memory allocation.
Both are used in dynamic memory allocation. Okay, thank you. Okay. Next, anybody? Anybody can give the correct answer, exact answer?
Hello, sir.
Ovidu, please.
Sir, malloc takes only one argument.
What is the difference between malloc and calloc?
Hello, sir. Hello, sir. Malloc takes only one argument,
Please continue.
and it defines the size of the memory block in bytes. But in case of calloc, it takes 2 arguments. One represents the number of variables, and another says the size of each variables.
That means you can allocate multiple memory area of particular type. It may be integer, it may be character, it may be float, and it may be your structure which you have defined, or it may be union, and multiple memory location of that particular type you can allocate with the help of calloc,
Yes, sir.
isn't it? So you can say, if you want to say, sorry, if you want to create an array, then you can take the advantage of calloc. And if you want to create only single memory location of a particular type, then you can use calloc, sorry, the malloc.
Yes, sir.
So using calloc, you can create an array, and using malloc, a specific type, isn't it? And what is the difference between realloc
Sir,
and calloc, or realloc and
so
malloc?
when we
Where
use
you can
malloc
use
or calloc,
realloc?
and after running, and after some time, if we think that we need some extra space, so realloc is used for reallocation of memory blocks. Means I want some extra space.
Thank you so much. That means if the memory is available, if it is available, then you can allocate, reallocate the memory area. Thank you. Shomodeep. Shomodeep
Yes, sir.
Bhaunik,
Yes, sir.
can you tell me what is the return type of malloc and calloc?
Void pointer.
Void pointer. Thank you so much. Why void pointer?
Sir, void pointer because after returning the void pointer, we can typecast it to integer or character, whichever we want. Means it doesn't have a
Thank you.
predefined.
Exactly.
Data.
Exactly. Thank you so much. So this particular memory area basically used. That means the heap section is used for your dynamic memory allocation. And suppose you want to create a linked list, then after creation of one node, you may ask to the end user whether you want to create another node, and so on. And if you want to delete the particular node on not, then what will happen? Based on your requirement, heap section grows in upward direction according to this diagram. And what about the stack section? So if this between the stack section and heap section, this memory area is vacant for the time being. Now, according to your requirement, that means the requirement of your program, heap section will grow in the upward direction and stack section will grow in the downward direction. So, what is the use of stack section? You know what is stack? What is stack section? Why local variables are stored here? Can you explain this with the help of any example? Anybody, please? Anybody?
So that the least used variable goes at the bottom.
Can you please tell your name?
Sir Janvi.
Janvi. These are the variables. Suppose I want to execute one recursive program. Okay. In case of your recursive program, it will call itself again and again. So where to store those variables? Intermediate variables means, suppose I want to take a specific example. I want to calculate the factorial of a number. So what will happen? For a particular number, so factorial, I take a particular number, that is factorial 5 I want to calculate. So that is equals to 5 into factorial 4. So again you have to call the same function, that is factorial 4 with n minus 1, that is 5 minus 1. So again, so 5 into factorial 4. So what about the 5 into? Where to store that intermediate result? Have done calculation, where to store? You have to store
Yes,
that
sir.
particular have done calculation within the stack section. Put it in the stack. Next, okay, thank you, Janvi. So next time it will call itself again with a new value, that is 4. Again it will call itself new value. How long this will continue? Unless and until it encounters the uh, terminating condition. That means, what is the terminating condition? That is factorial 0 equals to 1. That is the terminating condition. So unless and until it encounters the terminating condition, that is equals to factorial 0 equals to 1, it will continue. It will call itself again and again, and intermediate results will be stored within the stack section. So you have to preserve all those values, because if you don't preserve all those values, you cannot get the ultimate result, because at the time of call return, when it will return value to the previous instance, then it can complete the smaller sub problem, that is factorial 1. Ultimately the value will be 1, and it will return the value 1 to the previous sub problem, that is factorial 2. So that will be equals to something, and in this way it will continue. And first, we know what is a push and pop operation. So first it will push all those values within the stack, and ultimately it will return all those values from the stack. So this portion, stack section, will be used for that, not only in case of your recursive call only. This stack section, suppose for non-recursive call, like suppose function A calls function B, and function B again calls function C, function C may call function D. So all the values, all the not only the data values, it may be some other values also, that means register values other than this, may be stored here. So local data portion, that is the stack section, will be used for that. And if so the stack section will grow in the downward direction, heap section will grow in the upward direction, unless and until there is a space. If there is no space, then it will generate some error, obviously. So this is the allocated memory for a particular process. This is a schematic diagram, you can say, for a particular process. Now, how to create a process? So there are few system calls through which you can access some basic fundamental operations of your operating system. Fork is one of them. So using fork system call, you can create a process. So what is that? Suppose within your process you have written fork system call. So that is with this particular call operating system, if the resources are available, then it will create a process. So according to this diagram, P1 creates a process, P2. P1 is known as the parent process, and P2 is known as the child process. Now, in most of the operating system, as you know, most of the operating system are written in C language. So it is implemented through some functions. It is fork in case of your Unix like operating system. Just a minute, somebody wants to join and discuss. Okay, so what it will return, or after successful execution of fork system call, it will return the process ID of the child process to the parent process, and fork will return 0 to the child process. It is very interesting. That is, a particular system call returns two values simultaneously. In case of your successful execution, it will return the process ID of the child process to the parent process, and it will return 0 to the child process. Okay, so it may execute the same code section, but based on the return value, we can identify whether this is a child process or it is a parent process. And based on that, you can execute different codes for child process and parent process. Is it clear?
Sir, can you please repeat again?
Okay. Fork is a system call in most of the operating system like Unix, Fedora, etc. Solaris. This particular system call is implemented through a function that is fork, and this particular system call returns two values: 0 to the child process and the PID, that is the process ID, to the parent process. So after successful execution, parent, where that particular fork is written within the code, and suppose process 1 executing that particular code, and after few lines it encounters there is a fork system call. So what will happen? If it is successful, after the successful execution of this fork system call, it will return the process ID of the child process to the parent process, and it will return 0 to the child process. At this moment, both will execute the same program, that is the same code. Okay. Now, what will happen? If it is unsuccessful, it will return -1. If it is unsuccessful, fork will return -1, and if it is successful, then it will return process ID of the child process to the parent and process ID of the 0 to the child process. Now, the fun with fork. Now, can you tell me what will be the output of this particular code? Hash include stdio.h. Just tell me whether this is visible from your end or not. Can you see this particular code segment program?
Yes, sir, we can see this one.
Okay, thank you. Hash include stdio.h, int main void, int PID, system clear, nothing is there. So PID equals to fork. So fork will return something that will be stored within PID and nothing else. Now there is a printf hello world. So what will be the output of this program? What will be the output of this program? If it is successful, it will return 0 to the child process and PID of the child process to the parent process. So as I told you in my previous class, each process should have unique process ID by which you can identify that particular process within a current session. Okay, so each process will have unique process ID, so by which you can identify a process. So it will create, if it is successful, obviously it will create a particular child process, parent process will create child process, and after that there is a hello world. So what will be the output?
So the output will be hello world.
Output will be
Sir, hello world.
hello world. It obviously hello world, but hello world will be printed twice. Why? Hello, this will be the output. Okay.
Hello.
Hello.
Hello, sir.
Hello.
Hello.
Please tell your name.
Sir, my name is Chirag.
Chirag. Okay.
Sir, why
What's your name?
sir, why it will print 2 times hello world?
I'm just explaining why it will print 2 times. Just a minute. See, whenever a particular process is created, it will attach its biodata with it. That means operating system will allocate some memory area, and at the same time there is a specific location that is solely allocated for the operating system's own use. That means that particular any other process cannot access those that particular memory area, and there it will maintain the process control block for each process, newly created process or the existing running processes. It will create the biodata of all the processes. Now, what are the data members? As you know, it will store process ID, program counter, register values, memory related information. That means what are the different resources, that means files are allocated, etc. So everything will be preserved here. Now, there is a entry that is program counter. So what is program counter? Program counter basically stores the next instruction to be executed. So there will be a process control block for P1 and there will be a process control block for P2. When process 1, P1 creates a new process, it will just copy almost all the values from PCB1 to PCB2. Almost all the value. That means it will not copy the process ID, obviously. Process ID will be unique for each process, but it will copy the program counter. So at the time of creation of the new process, the program counter value of the parent process will be exactly same as the program counter value of the process 2, that is the child process. Is it clear? So whenever a particular process is created, whenever parent process creates a child process, it will copy almost all the values from PCB1 to PCB2, including program counter. Okay, so now see this particular program again. So int PID system clear. So P1 will execute system clear. P1 will execute PID equals to 4. So when it will execute PID equals to 4, at that particular moment, the program counter will store the base address of the next instruction to be executed. Now, what is the next instruction to be executed? That is hello world. So this is the, just a minute. I think somebody wants to join. Okay. So whenever it will execute PID equals to 4, the program counter will store the base address of the next instruction to be executed, that is the base address of printf hello world. Now, after the successful execution of PID equals to 4, it will create the child process. New biodata will be attached with the child process, that is P2. Almost all the values of P1, excluding few values like your process ID, almost all the values will be copied from PCB1 to PCB2. So program counter will be same for the child process. Now child process will not start its execution from system clear, it will start from printf hello world. That means for this particular program, child process will execute only one statement, that is hello world. But parent process will execute system clear. Parent process will execute PID equals to 4, and then it will execute printf hello world. But the child process will execute only one statement, that is printf hello world. That's why the last statement will be executed by both the parent process and child process, and you will get this particular output, that is hello world twice. Is it clear? Is it clear?
Yes, yes.
Thank you. Thank you. If you have any doubt, I will leave it again. Okay. Now, as I told you, when it will successfully return -1 to the parent process. Now, can you tell me what will be the output of this particular program? The same thing, only I have inserted another for. before hello world. That means there are two pops. Take your copy and try this one. Try to execute this one. Try to guess the output.
Sir, -1.
No, why -1? If it is unsuccessful, then only it will return -1. If it is successful, then if the resources is not available, sufficient memory area is not available, etc., then you cannot operating system cannot create a new process. Then you will return -1. If it is there, now it is resources not a problem.
Sir, it returns -1 to the parent process.
Why?
But if the program is failed, unsuccessful.
If it is successful, if the resources are available, then
No, I'm just asking that if the program is unsuccessful, then it will return -1 to parent process or child.
parent process. Child access is obviously return the value of the parent process. There is no option, no other option. Isn't it? So just tell me what suppose in case of the successful execution of the object, what will be the output? Why is this?
Sir, hello world dice.
Hello world, why?
I'm
Please tell your name.
PID. So
Please tell. What will you thank you for your attempt, but actually what happened? Just see the diagram. First is the executable statement. First executable statement is system clear. Just is that you will be executed by the parent process P1. Next is parent process will encounter PID equals there is only one process at that particular moment. One other process there. So only one will execute PID equals for that first instruction. First instruction. So what will create P2. Okay. Now the program P1 and P2 will point the second for statement. Next instruction is executed. So when we execute the next instruction that the idea was for. So what will happen? P1 will for another process that is PID and P2 will for another process that is P4. Okay. Now this is one. So at the beginning there is one process P1 will execute PID equals 4. After that, the next instruction, one will be created and P2 will be there. P1 and P2 would execute the second instruction that is equals 4. After that, how many processes there are 4 processes that is P1, P2, P3, and P4. All execute the last statement. Hello world. So how many hello world is there? 1, 2, 3, 4. This will be the output. See this carefully. This is having now various field processing. Anybody? Very interesting. Don't be confused.
Can you explain this one thing that how is implementing like parent program is pointing once PID for
Exactly. Initially only one process that is P1. Only one process was there. Only one process that is P1. Is it clear? P1 will execute system here. Then it will execute the next instruction to be executed because that is stored in the program counter. So it will P1 only is there and P1 will execute PID equals 4. After successful execution, we will form a new process that is P2. So at this moment, there are two processes, one is P1 and P2. Okay. Now the next instruction, that is now the program counter of P1 and P2 will point to the next instruction, that is another PID equals false. So both will point to this particular instruction, that is second false instruction. So P1 will execute PID equals false, and P2 will execute PID equals false. Isn't it? Now, how many processes are there? P1 will form another process, that is P3. P2 will form another process P4. P4. Okay. So how many processes are there at this particular moment? 4 processes are there. Okay. Now see this program again. That is system clear. Only 10 process is there. P1 will execute that. After that, PID equals false. So there is only process, that is P1 will execute this PID equals to false. After that, there will be two processes, that is P1 and P2. So P1 will execute and P2 will execute this false statement, because the program counter points to this particular statement only. P1 will not, P2 will not start from system here. It will start from the second false instruction. Here.
Thank you, sir. Yes, thank you.
So after that, there are 4 processes, that is P1, P2, P3, and P4. So the program counter for all the 4 processes will point to the base address of this particular instruction, that is the last instruction, that is printf hello world. Okay, so P1, P2, P3, P4 will execute this one, printf hello world. Just follow the asterisk mark. So how many printf will be there? Hello world 4. So you will get this one. Is it clear?
Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you. If you have any doubt, anybody please, I will explain it again. Don't be confused. This is very interesting.
Hello, sir.
Hello.
Hello, sir.
Hello.
Hello,
What's
sir.
your name?
Sir, Chirag.
Hello. Chirag.
Sir, can you show the program once again in the screen?
This one?
Sir, this one, yes.
If you have any doubt, clear it at this moment.
Sir,
Hello. Please tell
hello,
me.
sir. Sir, if PID is called above system clear, then in that case, will it execute 2 instructions?
PID is
It's
placed
called-
above system. System clear basically clears the screen, that is the standard output and nothing else.
Okay, sir.
Okay.
Thank
It
you.
will not clear the variable. It will just like your CLR SCR in your Turbo C.
Yes.
This one is universal in case of your ANSYS C. Everywhere it will execute, but CLR SCR is specific to Turbo environment. Is there any doubt? Chirag?
No doubts.
Okay, thank you.
Thank you, sir.
Okay. Now, the conclusion, the number of processes equals to, in this particular case, equals to 4, isn't it? So 4, that means equal to 2 square, that is equals to 2 to the power n, where n is the number of system calls, port system call. So why this is 2? Because from one port you will get the parent process and child process, that is you cannot create more than one child. So according to this diagram, there is a tree-like structure. If you consider this one, there is like this. So ultimately you will get this. So now where n is the number of port system call. Based on that, you can calculate what will be the output, how many output will be there. Now, if I write PID equals to 4 times, after that, if I write hello world, what will happen? How many times
Sir,
it will print?
16
hello world. 16 hello world.
16. 16 hello world will be there. Thank you. This will be the output. Now, see this one. Hash include stdio.h. System clear, PID equals to 4. If PID greater than 0, printf parent process. As I told you, if why PID greater than 0, as you know that after successful execution of your for, it will return the PID of the child process. So if it accept the positive value, that indicates this is the parent process. So child PID of a particular process cannot be 0. So if it returns a positive greater than 0 value, uh, that means that indicates this is a parent process, and you can print the PID of a particular process using get PID function. So if you write this one, you can print the PID of the process. So in this particular case, if PID greater than 0, that indicates this one is the parent process, and it will print the parent process ID. And if it is -1, it will print, that means this one is unsuccessful, it will print process cannot be created. Else, printf child process. That means if it is 0, if it is not, if it is greater than 0, if it is -1, and if it is other than that, that means if it is 0, that indicates this is a child process. It will print the PID of the parent, PID of the particular child process, as well as the PPID. What is PPID? PPID is the parent process ID. So using get PID, you can get the PID of the particular process, and using get PPID, you can get the parent process ID. So in this way, you can see the process ID of a particular process and process ID of the parent process of that particular process. So from this particular program, you can check whether this is the parent process of this particular newly created child process or not. So you can, parent process will print the PID, say this is 3902, and child process will print the parent process ID, that will be also 3902 if it is 3902 for a particular process and particular session. So from there you can check whether this is the parent of this particular child process or not. Is it clear? Very simple program. Is it clear? So using get PID, you can get the, hello, is it clear?
Yes, sir.
Yes, sir.
So
Yes,
using
sir.
sir,
Anybody?
one thing, sir. So using get PID, we will get the process ID, and using get PPID, we will get the parent process ID.
Parent
Right?
process ID, exactly. Is it clear now?
Yes, sir.
Okay. So in this way, you can, after writing the POC statement, suppose you want to execute a particular code segment for your parent process and the separate code segment for your child process, you can write in this way. That means if it is parent process, after creation of the after creation of the child process, it will execute the if portion, that is if PID equals to 0, parent will execute that particular specific portion, and child will execute the else part. Okay, so obviously we get different output. Now, not only that, you can also override the code segment at this, the in this particular example which I have already shown, that is both will, this one, both will execute the same code. That means code segment or code section is same, but you can override the code section of the newly created child process with different code. After the creation, you can erase the code section for child process, and you can rewrite it. That means after creation, child will entirely execute different thing. That means it will use separate code section. That is also possible. For that, there is another system called, that is exec system call. So next day we will discuss about that. Already there is class for the next. Which class is there according to your schedule? From 120.
Sir, there is SMSS class from 3:30 p.m.
No, according to schedule, there is a math class, I think. Okay, okay. I will tell only another particular thing. Just a minute. Just a minute. Now, what is this? I have already told you that there is a queue of processes. In the ready queue, it may be waiting queue. Now, how you can implement this queue? It's a very interesting diagram. I have taken this diagram from your Galvin book, page number 111. So there are different PCB, process control blocks. Okay, and using process control block, obviously this is a data structure, and using struct you can implement this data structure, and there is a provision. This is a self-referential structure. There is a provision to point the PCB of another process. So it will be a linked list. So using linked list, each node will be a PCB. So using this, you can create a linked list, and that will be treated as a queue. Okay. So with the help of this linked list, operating system will select which process, what are the different processes will be there in the ready queue, what are the different processes will be there in the waiting queue, and which process to fetch. There is different data members, as you know. You can also set another data member within this, that is your priority of the process. So based on the priority also, you can select a particular process from the queue, and you can assign the resource from this queue. So obviously there will be a head and tail pointer. So as you know, with a head pointer you can identify the first node, and the tail pointer you can identify the last node, and the last node is basically that what is the next of the last node. Obviously that will be null. So the first thing is, that is the ready queue. So how to implement the ready queue? There will be a linked list by which you can implement this one. That means first will be one PCB7, then there is PCB2. All are basically linked. Okay. Similarly, within this, you can also use this one. That is, there are different PCBs will be there, because some processes will be in your memory, and some processes you may have to store all those processes to the temporarily to the disk also. In that particular case, it may so happen that it may be stored within your tape also, magnetic tape also. So in this way, with the help of linked list, where each node will be process control block, you can maintain a queue. Operating system maintains a queue. Why? Because different processes are allocated in different memory location. All the processes may not be contiguous in nature. So how to track them? So if you know the PCB, you can easily identify what is the starting address, base address of that particular process. What is the length of that particular process? So from where to where it has been allocated. Okay. So everything is there. So if you know everything in detail, you can easily access them. With the help of this biodata, it will maintain the queue. Is it clear? Why PCB is so important? It actually distinguishing factor, one of the important factor by which you can identify this is the process or not. You have written a program that is inactive. Whenever that will be in execution, operating system will attach this biodata, and every time process will be referred, every time process will be accessed with the help of this biodata. All the information, operating system related information will be stored here. The state of the process, register values, etc., all will be stored here. Okay. If you have any doubt, please feel free to ask me. See this particular diagram, that is from page number 116 from this book. That is what is the in the Linux operating system. This is a tree of processes on typical Linux operating system. In it is the parent of all the processes, and it has process ID equals to 1. Then there is separate login for login. There is a process ID equals to 8415. It's not fixed. This is for a particular session. Similarly, there are different SSHDs, another process, so it will again fork another thing. So login, from there, login, you have to select which process will be there. That is bash. That is the shell which will be ready to accept your command. So it should have, since this is a shell is also a separate process, it should have separate PID. It may be 8416 for a specific session, etc., etc. So again, it will fork another processes. So in this way, it will create a process tree. Now, what actually happens? Suppose a process, all the process related informations are stored in a table that is known as process table. Suppose a particular process, whenever a particular process expires, that means it terminates, then the related information will be given to the parent process. That means parent will be notified, and before notification, if it terminates, then what will happen? The entry will be there in the process table. It will be treated as zombie process. That means parent will not be notified. That means parent, the parent process is there, child process is there, but actually that is not there. So this one is known as your zombie process. And what is orphan process? Normally, parent process waits for the termination of the child process. If parent expires before the parent expires before the completion of the execution of the child process, then what will happen? It will become orphan process. So who will take care about the orphan processes? Init will take care about the orphan processes. Okay. So what is zombie process? Zombie process means process, one child process is terminated, and that is not notified to the, informed to the parent process. Okay. So child related informations are currently there in the process table. So it will become zombie to the parent process. And what is orphan process? Orphan process means parent process terminates before the termination of your child process. So who will take care about the child process? Init will take care about the child process at that particular moment. Okay. So next day I will continue. Today after this. So if you have any doubt, you may ask me.
Sir, can you please share this PPT with us?
Which one?
The PowerPoint
PPT
presentation.
one. Okay. I will share this.
Thank you, sir.
Okay, I will share this to your classroom, and try to join. Try to accept the invitation to the classroom.
Yes, okay.
Okay, I will share this. Don't leave this meeting. I will take your attendance.